Hello and welcome back. We're going to continue on our linear inequalities. We're going to start solving right now. And the thing about solving is it's very similar to solving equations, to solving inequalities. So I thought we should take a quick review of solving equations. So if we look at this first one, and on your note sheet you have a space to fill these out. So in fact what you probably should do is pause the video real quick and then go in and solve the ones that you can, and then come back in and check your work. So if you've solved them, the first one, we've got no adding or subtracting, so we're just going to divide both sides by 2, and we get x equal to 5. If we wanted to check that, we put that 5 back in. 2 times 5 is 10. Check. This one, we have something that we need to get rid of to get the x by itself, or we're going to subtract 5 from both sides. So that gives us x equal to 5, and there's no number associated with the x, so we're done. And again, if we check it, 5 plus 5, 10. Check. All right, so let's move down here a little bit, maybe. There we go. And we'll do a couple more. This one is, we have to subtract our 5 because we don't want anything with our x. So we've got 2x equal to 10. And now, since we have something multiplied, we need to divide. So again, x equals 5. So 5 times 2 is 10 plus 5, 15. That one checks. And then finally, on this last one, we have x's on both sides. So if you remember your foldable, it says to subtract the smallest one. So that gives us 2x plus 2 equal to 8. And then we would, whoops, oh sorry, this is a 2 here as well. There we go, plus 2. So we're going to subtract 2, we get 6 equals 2x. And we would then again divide by our 2. And so x would equal 3. So if we check that, 3 times 3 is 9, plus 8 is 17. 5 times 3 is 15, plus 2, 17. Again, that checks. So hopefully you check those on your papers as well. And then we have just a few more. So let's go through these real quick, just so that you can get some practice back into solving equations. So we have 3x equals 12. We now have a 3 with our x, so we have to divide by 3. So x equals 4. Okay, 3 times 4 is 12, plus 4 is 16, so that checks. And again, on this one, we have 2 variables, so we subtract the smallest one, and that gives us x plus 8 equals 10. We would subtract 8, and that gives us 2 equal x. So 2 times 4 is 8 plus 10 is 18. And 5 times 2 is 10 plus 8, 18. So again, that checks. And I believe there was one more down here. There we go. So we'll do our one more. Again, we only have constants, so we'll get rid of this one, always doing the opposite. And then we have 2x, and then a negative 11 plus 5 is a negative 6. Divide by 2, divide by 2, x equals negative 3. So negative 3 times 2 is negative 6. Negative 6 plus 5 is negative 11. Again, that checks. So now that we've had a quick review on solving equations, let's move on to what we're going to be talking about today. And in your notes, you have a place to fill in some of this information. I put some of it there for you, so mainly you're filling in. We want to look at solving and graphing linear inequalities. So we're working with inequalities now, and not just equations. And so when we solve linear inequalities, you're using the same strategies as when we solve linear equations. The only thing we're doing now is using the order operations in reverse, and then we're using inverse properties, just like we did when we solved equations. So a quick review from last week. We had the inequalities. Now you want to remember that your lesson, and I noticed this on some of your homework, remember the less than or equal to, this is a filled in circle, this is an open circle, this is an open circle, this is a filled in circle. If it's equal, you've got the filled in circle. And when you read these, you're reading them. 5 is less than 6. 5 is less than 6. X is greater than 2. Okay, if the X is on this side, you want to say the X first, so you work backwards. So then you would have X is greater than 1. Okay, so you work this direction. And you want to be careful with that because when you're graphing some of these, there are a lot of mistakes on the which way the arrow should run. So if you're unsure about that, please go back and check that out again. So if we're going to graph X equal to 2, that is just a filled in circle at 2 because that is the only point that's included. Now if we're graphing X is greater than 2, that's an open circle, and greater than is going to go to the right. All right? So that's a review of last time. You do not shade the circle on this one because there's no equal to sign, just greater than. But if you go down here where there is an equal to sign, now you will shade the circle in and go forward. Okay? So be sure and be very careful with that. I know that's a detail, but a lot of you are just putting a circle and moving on, and you have to actually understand what that circle is telling you. Sorry, this is a review. Remember, less than equal to are filled in, and then not equal to open. Okay, you should have that in your notes from last week. So if you don't, make sure you add it in. All right, so we're going to look at how to solve linear inequality, and what we're going to do is kind of solve a equality equation, and then do the same steps on the inequality. So you can follow along with this in your notes. So the first thing on the equality or the equal equation we're going to do is add 2. Because we need to get rid of our number that's with our variable. So that makes that, 20. All right, and then we will go over here. We're going to do the same thing. There's nothing different about what we're going to do. So now we have 4x is greater than 20. Okay? The difference between an inequality and an equation is equation you're getting one answer, and in an inequality you're getting a range of answers, everything greater than a certain number. So if we go back to our equation, the next step would be to divide by 4. And we get x is equal to 5. And so over here we're going to do the same thing. Divide by 4, and we get x is greater than 5. Okay? So that's how you would solve both of those. And then to put them on the graph, just like we were talking about before, if it's equal, you just put a circle at the 5. Since this one is greater than, not equal, we put an open circle, and we want everything greater than. So basically you're doing pretty much the same thing. Okay? They're almost the same thing. We solved it, we did our same steps, we graphed it, looking at our closed and open circle, depending on if it's equal to or greater than. Okay? So that's how you would walk through that. Let's just take a look at these. We have, and you can put as much of this information in those boxes as you feel comfortable so that you understand what these are. We talked about the properties, and we're still talking about the property of equality, but it's also a property of inequality. If we add the same number to both sides or subtract the same number to both sides, the inequality is still true. Okay? So it's still a property, it's still the same equation. When we look at the inequality property of multiplying or dividing, again, if we divide both of these sides by 2, it's still true. But if we divide them by a -2, it is no longer true. Okay? So we have a condition we have to meet when we're multiplying or dividing. Oops, here we'll do dividing also. Dividing by 2, true. Dividing by -2, or -2, not true. So the thing that we have to always remember, when you multiply or divide inequality by a negative number, you have to reverse the sign. Okay? So if we go back and look at this, we looked at this, these are not true. However, if we went in and reversed this sign and said -10 is less than -4, now it's true. Or -4 is less than -1, now it's true. So if you are multiplying or dividing by a negative number, the only difference about solving inequalities is if you're dividing or multiplying by a negative number, you must reverse the inequality sign to make the statement true. All right, so let's look at this example. We're going to do the same thing we've been doing. Subtract 1, and that leaves us negative 3x less than negative 15. Okay? Now, the constant or the coefficient in front of the x is negative, so I'm dividing by negative 3. So I get x. I need to flip that sign, and then I get 5. Okay? So we don't flip the sign until after we do the division. We're dividing by negative 3. Because we're dividing by a negative number, we have to flip the sign. Okay? So make sure that when you write these notes, you remind yourself to flip the sign when you divide by a negative number or multiply by a negative number. Let's try one more. Again, like we talked about before, we have variables on both sides. So we're going to subtract the 2x. That gives us 2x plus 12. We're going to subtract 12. We get negative 14, 2x. And since this is positive, we divide by 2. X is less than or equal to negative 7. Now, because that x is on the right, it just doesn't flow well. So we're going to rewrite that with our x on the left. When we do that, just like if we were multiplying by a negative, we have to keep this the same as it is relative to the x. See, it's less than on that side of the x. So this is your solution. So if we were going to graph that, 0, what are we at? Negative, what did we say? Negative 7? Yeah. And we're going to go less than or equal to, draw this closed circle, and it was going to go to the left. All right? So there's some examples. You have a practice sheet that I want you to do. And then there is a little Google form. You have to fill in the answer to one question, and it's on there. So this is the question. How would you fill this in? Solving inequalities and equations are pretty much the same, except for one rule that changes. So fill in that one rule and put that on your Google Classroom. And for those of you that are watching closely, here is that rule. You multiply or divide both sides, you have to reverse the sign. That is the one